Hello guys, welcome to the IDA course. Today we're going to be talking about variability. So as we studied, we saw a lot about local estimates, but local estimates is just one dimension. When we are going to analyze a feature or a column, we also have a second dimension that is called variability estimates. And the most widely used estimate of variation are basically based on deviations or difference between the local estimate that we calculate and the observed data. So we have here an example where we have a set of data with 4 values, 3, 5, 4, and 4. If we would calculate the mean, right, as a local estimate for this set of data, we would obtain a mean equals to 4. So to calculate the deviations, we need to calculate the difference between this local estimate that we calculate here and each of the values in our set of data. So we would have something like 3 minus 4, okay, that would result in -1. We would have 5 minus 4, that is equal to 1. 4 minus 4 is equal to 0, and also 4 minus 4, that is equal to 0. So here we have the calculated deviations, that is -1, 1, 0, and 0. And we have a challenge here that is basically estimate, right, a central value from these calculate deviations, and a few options come to mind when we are going to do it, and is take the average between the 4 deviations. But as you guys are seeing, the negative values makes for the positive values, and they would not be useful. And the other option is to sum, right, the 4 deviations, but the result would be precisely 0, and that would not help us either. Another option is use the best well-known estimates for calculate variability, and it is the variance and the standard deviation, which are based on square deviations, and the variance is basically an average of the square deviations, and the standard deviations is the square root of the variance. So we have here the formula for the variance, okay, and here for the standard deviation. So basically we take the difference, right, between the local estimate and each data point. We have now a set of data, we square, right, this difference, and we take the average for each data point we have in our set of values. So you guys would probably be thinking why we have here n minus 1 instead of n, right? Because if this is the mean, we should have the number of variance here, and that is basically because we have something called degrees of freedoms when we are going to work with samples, and I'm going to explain to you guys later when we are going to dive a little bit into it. But for now, so you guys understand, we have this n minus 1 because of the degrees of freedom instead of only n. And we also have the standard deviation, that is basically the square root of the variance, And the standard deviation is the most used estimate to explain variability, because the result is the same scale as our number in our feature columns or data sets, so it's easy to explain and analyze when we are going to explore the variability in our set of data.